Hi students, chemical reactions and equations from chapter number 1 of your 10th standard science NCERT textbook. What is a chemical reaction? Before defining a chemical reaction, let us check some important chemical reactions from the daily life. Burning wood, souring milk, mixing acid and base, digesting food, photosynthesis, cooking food, heating sugar to form caramel, rusting of iron. These are some important examples for chemical reactions which are close to our daily life. Now we can define a chemical reaction. Chemical reaction is a process in which one or more substances that are called the reactants are converted to one or more different substances, the products. Substances are either chemical elements or compounds. This means generally we are representing a chemical reactions as reactants in the left hand side and the products in the right hand side. And these reactants and products can be elements or compounds. What is the difference between an element and compound? Elements are pure substances which are composed of only one type of atom, where compounds are substances which are formed by two or more different types of elements. Let us write some examples for elements and compounds. If hydrogen is an element, H2O water is a compound. If calcium is an element, calcium hydroxide is a compound. Okay, for elements, single type of atom is present. But for compounds, see, two different atoms are here, hydrogen and oxygen. In this, three different types of atoms are there, calcium, oxygen and hydrogen. So, this is the difference between an element and a compound. If I write a chemical equation like H2 plus O2 gives H2O, okay, in the reactant side, hydrogen and oxygen are elements, and in the product side the water is compound. Okay, if I write one more example like MgCl gives Mg plus Cl2, in the reactant side it is a compound, but in the product side elements. So elements and compounds, it can come for either the reactant side or the product side. It is not particular. What are the main changes take place in a chemical reaction? What are the most observable changes? Easily we can observe what are the changes takes place in a chemical reaction. That we are going to discuss now. The first one is change in state, then change in temperature, change in order, change in color, and finally evolution of gas. Change in state means any state change like solid to liquid, liquid to gas, okay, any and so on. Any change in state like gas to liquid, liquid to solid, solid to gas, okay, any state change it is possible in a chemical reaction. If there is a change in state, there will be definitely a change in temperature. If one substance is changing its state from one state to other state, there will be definitely a temperature increasing or temperature decreasing. So these two are interconnected. Then change in order. Change in smell. We can easily identify change in smell during a chemical reaction. Change in color. Any color change it is possible in a chemical reaction according to the reactants and product. Evolution of gas means the gases like hydrogen, oxygen or carbon dioxide. Okay, this kind of gases can be evolved during a chemical reaction. Then what is a chemical equation? The reactions which we can represent in form of equation using chemical formula is called a chemical equation. So now let us write a chemical equation again. Hydrogen and oxygen combine to form water. Okay. This is the chemical equation for the formation of water molecule. And now we can check the number of atoms in the reactant side and product side. Reactant side, the atoms are hydrogen and oxygen. Here also hydrogen and oxygen. The number of atoms, it's 2 here. Oxygen, it's 2 here. Hydrogen, it's 2. Oxygen, it is 1. Okay, for hydrogen and the reactant side and the product side, the number of atoms are equal. But for the oxygen, the reactant side, it is 2. In the product side, it is 1. It means this equation, it's not balanced. We have to balance this equation again. A chemical equation should be balanced for a chemical reaction. Why a chemical equation should be balanced always? A chemical equation should be balanced according to the law of conservation of mass. Mass can be neither created nor destroyed. It is converted from one form to another form. This is law of conservation of mass. It means any change it is possible in a chemical reaction, like change in state, change in temperature or change in color, anything, any change or conversion it is possible. But the mass, number of atoms should be equal for the reactant side and product side. How to balance an equation? This is one of the most important topic from this chapter. We will learn balancing equation with some examples. And see, there is no a particular method for balancing an equation. It is just a trial and error method. Here I am using two columns to represent the number of atoms in reactants and number of atoms in products. And here we will write the types of atoms in the reactants, and here we will write the types of atoms in the products. The types of atoms will be same only in reactants and product side. Only the difference will be there in the number of atoms, and finally we have to balance that. So I will write one example now. First I am writing the example. Zn, zinc, H2SO4, sulfuric acid. It reacts together to form zinc sulfate and hydrogen. Okay, this is our equation. Now I am going to write the types of atoms. Zinc, hydrogen, sulfur, oxygen. In product side also the same atoms will be there. Zinc, hydrogen, sulfur, oxygen. Always give the same order for the atoms. It will be easier to balance the equation. So Zn, the number of atoms I will write here. It is 1. For hydrogen it is 2. For sulfur it is 1. For oxygen it is 4. Here zinc 1, hydrogen it's 2, sulfur it's 1, oxygen it's 4. See the number of atoms in both the reactant and product side. Zinc is 1, hydrogen it's 2, here also it's 2, sulfur it's 1, here also it's 1, oxygen 4, product side also oxygen 4. This means this equation it is already balanced. We don't want to balance it again. So this equation is already balanced. Okay. And the next example, a very simple equation I will write here. Mg plus O2 gives MgO. Okay, this is our equation. So we will write the atoms here, magnesium and oxygen. Here also the same. And the number of atoms we can count. For magnesium it's 1, it's oxygen it's 2. For magnesium it's 1 here, oxygen it's 1. Here magnesium it is balanced, but oxygen here it's 2, here it's 1. So we should balance the oxygen atoms. To balance the oxygen atoms, I can change either in the reactant side or in the product side. That is not particular. But always we can increase the number of atoms. We cannot decrease while balancing. So here it's 2, here it's 1. So I will increase the oxygen atom number here by keeping a number 2 here. Now the oxygen is 2, oxygen is 2. Oxygen, it's balanced. But what about the magnesium? It was previously balanced, but now it became 2 in the product side. But in the reactant side, it's 1 only. So I have to balance the magnesium now. Okay, so I will keep a 2 here. So now it's balanced. 2, 2, 2, 2. This equation is balanced. And the other example we can write. Calcium sulfate, CaSO4 plus NaNO3 gives CaNO3 twice plus Na2SO4. This is our equation. So we will write the atoms here. Calcium, sulfur, oxygen, Na sodium, N nitrogen. Okay. Here also the same order I will write. Okay. Then calcium, it's 1. Sulfur, it's 1. For oxygen, calcium sulfate consists of oxygen. NaNO3 also consists of oxygen. So we have add together for getting the number of atoms of oxygen. So it's 4 plus 3 here. It's 7. And sodium, Na, it's 1. Nitrogen, it's 1. Calcium, it's here 1. And sulfur, it's 1. Oxygen, again here also oxygen, here also 4 oxygen atoms are there. So we have to add together. And this 2, okay, this 2, it is common for both nitrogen and oxygen. Okay, that's why we kept a bracket like this for nitrogen and oxygen. So 2 we should multiply for nitrogen and oxygen. Nitrogen, it's 2 here. And for oxygen, it is 3 into 2, 6. And here 4 oxygen atoms are there. So 6 plus 4, it's 10. And the sodium, it is 2. Okay. Now calcium, it's balanced. Sulfur also, it is balanced. But oxygen, sodium, nitrogen, it's not balanced. So first I will start with balancing oxygen. You can select any of these atoms to balance first. Here I am choosing just randomly, it's oxygen. Okay. So oxygen, it is 7, here it is 10. Okay, so we should increase the oxygen atoms in the reactant side. So oxygen 4 plus 3, 7 only. We should make it as 10. So if I keep a 2 here, see 2 into 3. This 2 is common for sodium, nitrogen and oxygen. So 2 into 3, 6 is the oxygen atoms here. And here again it's 4. So 6 plus 4, it's 10 now. Okay. By keeping a 2 here, what about sodium and nitrogen? Sodium, it's 2 now. Nitrogen also, it's 2 now. Okay. And calcium and sulfur, it's already balanced. Okay. Now the equation, it's balanced. This equation is pretty long, but with a number 2, the equation, it's completely balanced. And one more example, Fe, iron plus water gives iron oxide plus hydrogen. Okay, this is our equation. So we can write the atoms here: iron, hydrogen, oxygen, iron, hydrogen, oxygen. Iron, it's 1 here, hydrogen, it's 2 here, oxygen, it's 1 here. And here iron is 3, oxygen is 4 and hydrogen is 2. Hydrogen is balanced, but the iron and oxygen. It's not balanced. So first I will start with balancing iron. Here it's 3, here it's 1. So I can keep a 3 here. Then iron, it's balanced. Okay. Then oxygen, it's not balanced. Here it's 4, here it's 1. So I can increase the number of atoms here by keeping number 4. Then oxygen also balanced. Then what happened to hydrogen? It was previously balanced, but after balancing oxygen, hydrogen it's 8 now in the reactant side. But in the product side, it's 2 only. So I can keep a 4 here to balance hydrogen. Then hydrogen, it's 8 now. See, 384, 384. Our equation, it is balanced. So this is the method how we will balance an equation. What all we can add in a chemical equation to make the equation more precise, that we are going to discuss now. To make chemical equation as more informative, the physical states of the reactants and products are along with their chemical formula. Sometimes we can add temperature, pressure or catalyst. Catalyst means the substances we are using to speed up a chemical reaction in a chemical equation. So we can add the physical states of the reactants and products, or we can add at what temperature, at what pressure this reaction takes place, or the catalyst, that also we can add in a chemical equation. For representing the solid state, we are using the letter S. For liquid state, we are using the letter L. For gaseous states, it's G. And for aqueous solutions, we are using AQ. Okay. So let us write some examples now. I am writing the previous example of iron. 3Fe plus 4H2O gives Fe3O4 plus 4H2. Okay. Here iron, it's in a solid state. And H2O, normally it's a liquid, water it's a liquid, but here we are using as steam. Okay, so it's gaseous state. And iron oxide, definitely it's in solid state. And hydrogen, it's a gas, so it's in a gaseous state. Okay, so now the chemical equation, it's completed. And the other example I am writing here. CO, carbon monoxide plus hydrogen gives CH3OH. CH3OH is methanol. Okay, carbon monoxide, it's gas. Hydrogen, again it's gas. Methanol, like an alcohol, so it's a liquid. Okay, and this reaction takes place at 340 atmospheric pressure. That also I can represent here. Now this equation, it's complete. And the other example, 6CO2 plus 6H2O. This is the equation for photosynthesis. Okay, so I can represent photosynthesis. It's take place under sunlight and chlorophyll. Okay, so I can represent this also here. C6H12O6 plus 6O2. And carbon dioxide, it's in gaseous state, it's in liquid state. And this is glucose. Glucose is aqueous solution. And oxygen, again it's gas. Okay, so this is a complete chemical equation for photosynthesis. But the one thing you have to note here, usually the physical states or temperature or pressure or any catalyst, they are not included in a chemical equation unless it is necessary to specify them. Okay, so if it is necessary to specify in the answer, you have to specify all these in a chemical equation. Otherwise, you can just balance the equation mathematically and you can leave the equation as itself. Okay, So this is the concept about the chemical equation and balancing the chemical equation. Thank you for watching the video. Please like and share, and don't forget to subscribe the channel to get notification for new videos.